And we've already talked a little bit about 6.2. And I think I told you the difference between the two sections. If you include 6.1, 6.1 is basically finding the probability of a probability, or finding probability distribution, finding the mean and the standard deviation. And of course, the mean is also what we call the expected value. Okay, so that's predominantly 6.1. And I think I've already covered this with y'all, haven't I? 6.2, you're going to be dealing with finding the probability of X number of trials, meaning N being a fixed number of trials, P meaning a percentage or probability of those trials, and then X, what if I flip that coin 10 more times? Okay, so fixed number of trials, let's say we flip the coin 50 times and 25% came up heads. If I flip a coin 10 more times, what will the probability be that it will be heads? That's what we're going to be doing in 6.2, as well as mean is equal to N times P, and the standard deviation is equal to the square root of NPQ, and Q is equal to 1 minus P, which is the complement of P. So if P is 0.25, Q is 0.75. Now, I always like to go over this before we go over 6.2 because I want you to know the difference between the two sections. Okay? So in 6.1, you're finding the mean and the standard deviation of a probability distribution. And in 6.2, it's going to be a different type of question, and it's going to just ask you what is the probability or the mean or the standard deviation. And it's only giving you N, P, and X. Okay. So let me get back to the slide now. And didn't I cover this? Didn't I go over this with y'all? I get y'all mixed up with the 120-24. So does anybody look in your notes? Do you see this where I went over 6.1 and 6.2, kind of a summary?
Yeah.
Did?
Mm-hmm.
Okay, who was that talking?
It's Ms. Cameron.
Thank you. Thank you so much for interaction. It sure does help me out. I'm glad you're not weaned on a pickle. So let me get out of this. And here's our first formula. Now that formula is nice and all, but you're not going to use it. But I want you to write it down. P of X, the probability of X events, is equal to N combination X times P raised to the X power times Q. In all of my life as a math teacher, I've never seen Q written as 1 minus P in a formula until this book. Usually it's written as Q. So I'm going to call it Q. N combination X, P to the X power, Q to the N minus X. And all of those numbers are positive numbers. So there's the formula. And you just need to write that down because when we go over it in the calculator, I'm going to show you where that formula is in the calculator. You don't see it, but you punch the numbers in and it cranks out the probability. Oh, there, look at there. We already covered this in 6.1, but it's nice to cover it again. I'm going to leave that on the board so you can write it down, but you've already written it down. Write it down again. It's not going to hurt nothing. It's not going to hurt anything. And I brought cupcakes for everybody that came last week, and nobody came. So I wanted the students to know that those of you that came when I was overslept, I did bring y'all cupcakes. And no comment. This sucks. I hate classes that don't talk.
I'm sure they're saying thank you.
Well, thank you. You wasn't in here when I overslept, were you, Miss Cameron?
No, I was at home.
Okay. Miss Kylie Smith, I thought you were going to be here this morning. She's gone back to bed. She's washing clothes or went back to sleep, one of the two. I'm going to text my son while y'all are writing that down, make sure he's up and on the computer. COVID. All right, so again, we're going to do some examples here and you're going to see why those are important. I always tell people to draw a number line. It helps to draw a number line. I wonder what will happen if I use this. Where did this come from? Well, it's not working. And now it disappeared. There it is. Pen. See, it's doing the same thing. There's something wrong with this whiteboard application on the publisher. I mean, on PowerPoint. There's something not jiving. Okay, so here's an example. Oh, now my mouse is acting up. My Lord. Y'all see my mouse is acting up. See, and that's why I'd rather just do things at home. Now, 137 downstairs, I don't have problems out of 137. Now, that mouse is not supposed to be doing that.
We can't hear you.
I'm here. I'm so sorry. I'm just aggravated. This is every time I come to this campus, and yes, it is a direct reflect upon Tri-County Tech. Their rooms are not set up. They're not 100%. And every time I come here, I run into a problem. So I apologize. Now I got to set up everything. Just hold up a minute. Let's see. I need to make this display. I appreciate y'all being patient because I'm not. I don't think I'm ever going to get through 6.2. No, I don't want no wood up. Oh my God. Oh man. If we have class again Tuesday, we're having it in AC 137 because I'm not going to fool with this crap anymore. AC 137 is the only room that works. And that's because I've been in it for 3 years. I don't have to do all this. All right, so here we are. We're back to where we were. And I hope I'm still recording. Am I still recording, everybody? Now I can't get rid of this. Are y'all still there? Somebody say something.
Yes.
Okay, good. All right, so you can find this formula right here under second vars, and it's down here in binomial PDF.
We can't see your screen.
Oh, God. I'm about ready to scream. There, now you should be able to see it. Again,
Yes.
I apologize. You're only as good as your equipment. Okay, second vars, binomial PDF, and I'd like for you to put precise beside that PDF, that P, I say precise. In other words, equals. So when the difference between PDF and CDF is cumulative. So you need to put that beside that in your notes. Binomial PDF is equal to, and binomial CDF is cumulative. Okay. Make sure your mics are muted. I got background noise coming in, please. Did y'all hear me? Make sure your mic's muted. Miss Cameron, could you mute yours? I hate to mute yours.
Yeah, sorry.
That's all right. And we talked about this. And here is our first example. And I don't want, great. They show you how to do it. I don't want them to show you how to do it. Oh, okay. Just ignore this right here because we're going to do it together. According to the Experian Automotive, 35% of all car-owning households have 3 or more cars. Now, I wish they had not chose 3 or more cars. I wish they just said 3 cars because a lot of you might think that has to do with the inequalities. It doesn't. Just mark out or more. Just say 3 cars, okay? Because you're going to get that mixed up with the inequalities. This has nothing to do with the inequalities, okay? So I just tell students to put 3 cars. All right, 35%, there's your percentage. So you have P right there. There's P right there. P is 0.35, so Q is 0.65. Now, I can't write on this because if I tried to write on it, it might start doing that flickering thing again. And I don't want to do that. So I'm not going to try to write on it. Okay. And in a random sample of 20 car owning households, what is the probability that exactly, okay, I want you to highlight exactly and put an equal sign under it. When you see the word exactly, that means precise. That means exactly. That means equal to. 5 have 3 cars. Okay, so what have I always told you about N? N is always the what? Biggest what? Biggest number, Hubert. That's right, class. So which one is N? You got 3 numbers up there. Which one is N? $20, Hubert. That's right, class. Thank you for the input. 20 is N, so which one is X? 5, Hubert. That's right, class. Appreciate the input. So you're going to go to your handy dandy calculator and you're going to go binomial PDF and you're going to type in 20 fixed number of trials. P is 0.35. The calculator will automatically calculate Q after you put P in. And the X value is 5. And
wait, how did you get it on the calculator?
second bars, binomial PDF. Tell me when you got it. Second bars, binomial PDF. You got it? Yes or no? Somebody asked that. You got it?
Yeah, I'm just confused. Wait, I got the second bars, and then what's the next thing?
Go down, scroll down till you get the binomial PDF. And binomial PDF means precise, which means equals. And this exactly means equals. So hit binomial PDF and then type in what you need to type in.
Okay, thank you.
Okay. And now hit paste. And there is the probability, 0.1272. And usually probabilities are taken to 4 decimal points. So you write that down also. Usually probabilities are taken to 4 decimal places. Now this one's pretty simple. Why? Because it says exactly and you don't have to think too much. All right? It says exactly and you just type in PDF and you just type in the numbers and that's it. Okay? Now let's see what the next one says. And of course it shows you how to do it, but that's not. And what I tell students to do, when you got a question like this, draw a number line. Okay, so go ahead and write this question down. It's the same, 35% of cars have 35% of all households have 3 cars. Okay, in a random sample, what is the probability that less than? Okay, so I'm gonna let you write that down. Just write down the sentence. In a random sample of 20 households, what is the probability that less than 4 households have 3 cars? Now, what I tell students to do is write a number line. I'll go back to it in just a second. I tell students to draw a number line. And remember, there's no negatives on this number line. Because there's no negative households. And it goes up to, what did it say, 20 households? And I want you to, it says at least or less than 4. So remember, these are households, so there is no decimals and there are no fractions. We are dealing with nothing but what? Whole numbers, because you can't have half a house. Okay? So tell me what numbers are less than 4. What numbers are less than 4?
3, 2, 1, 0.
Is that Miss Dennis?
It sure is.
I thought you were coming up here. I got cupcakes for you.
I was coming up there, but I was going to be more late.
Okay, well, that's fine. I'm glad you could be with us today.
You really got cupcakes?
Yeah, I got cupcakes right here. See, I brought cupcakes for people that came and I was, see?
Oh.
Yep. Now I got to go home and give them to my cats because I don't want to eat them. All right, so I've got to do the probability of 0, and that's NP0, plus the probability of 1, that'd be NP1, and the probability of 2, that'll be NP2, plus the probability of 3, which will be NP3. And so I got to type in each one of those. We already got, what was the one we had a while ago? Was it equal to 4? Yeah, it was equal to 4, wasn't it? So we've got to type in 20, comma, 0.35, comma, 0, and do that one. And then 20, 0.35, and 1. then 20.35 and 2, and then 20.35 and 3, and add those up. So I'm going to show you how to do that on your calculator, but I'm going to show you how to do it two different ways. I'm going to show you how to do it the more difficult way, and then I'm going to show you how to do it the less difficult way. So, since we've got to do the blue dots, which is add up the probabilities of each one of those households, the probability of 0 households, plus the probability of 1 household, plus the probability of 2 households, plus the probability of 3 households. Now, why aren't we using 4? Because it says less than what? Less than 4 means that you don't touch 4, means that it is not inclusive of 4, meaning that it is exclusive. You do not use 4 because it's less than. Now, if it had equals to, less than or equal to, then that would be at most 4. And that's why you got to know the difference between the wording. So I'm going to go back to my handy dandy calculator. And I'm going to pull up the calculator. And I'm going to hit second, enter, and see it pulls up the last thing you did. And I'm just going to type in 0. Now you can write that number down, but I don't have a pencil. And I don't have a pen with me, so I can't write it down. So I'm going to stow it. Where do you get bread? That's stow. S-T-O right here. I'm going to stow that. I'm going to store it. The S-T-O means store. The reason I said that 3 different ways, stow, store, bread, I'm trying to get you to remember, if you want to store something, you hit stow. And then you give it a name. I'm going to call it alpha A. And I think A is right here, but I can't see at a 30-degree angle. It's another reason I hate this room. I can't see the daggum board. All right? And I stored that number in the spot for A. Okay, now I'm going to clear. And I'm going to do second, enter, second, enter. And there's my last, so I'm going to put 1, enter. And that's why this is good that I'm recording this, because you can go back and forth and rewind to see how to use the calculator. So I'm going to stow that, go into the stow, and I'm going to save that as alpha B. Clear. Second, enter, second, enter. And now I'm going to put in 2. I'm going to stow alpha C. Clear. Second, enter, second, enter. Now I'm going to type in 3. And I'm going to stow alpha D. Okay, I just did what they're doing right here. You see what they're doing right there? P of O, P of 1, P of 2, P of 3. I just typed in each one of those, and I stored them in A through D. Now I'm going to add everything. So alpha A plus alpha B plus alpha C plus alpha D. Ding! 0.0444.
You have a work email.
Now that's the hard way to do it. Now I'm going to show you the easy way to do it. Do you remember me telling you that C stands for cumulative? Cumulative means add up everything to the left. As you go over it, add up everything to the left. So I'm going to hit second, vars, binomial, CDF, and I'm going to type in 20.35. Does anybody know what I'm going to type in next? What value am I going to type in for the X value? What number are we going up to? I'm pointing at it right now. Comes after 2 and before 4. 3, Hubert. Thank you,
3.
class. And hit enter, and enter, and enter. Look at there. So binomial CDF can be used when you're accumulating numbers from the left all the way up to a certain number. So what do we say? In a random sample of 20 households, 20 homes, there is a 4% chance that 3 or less, or 4 or less, no, not 4 or less, less than 4 households have 3 cars. All right, let's look at the next one. Now, I want you to ignore this right here. I want you to, in a random sample, what is the probability that at least 4? At least 4. Now, the first thing I'm going to do, I'm going back to my number line. And we're going to change this right here. And I want you to graph on this number line, or your number line in your, before you even start the problem, I want you to graph at least 4. So take a minute, and if you haven't got a number line, I want you to draw one. So I'm going to take my handy dandy red marker, and somebody tell me what at least 4 means. Okay, it sounds like somebody was underwater.
It's 4 and everything above it.
Okay, that means that the lowest number is 4, right? So we're going to have to do NP4, NP5, NP6, NP7, NP8, NP9, all the numbers between 10 and 20. Who wants to do that? Nobody. So what are we going to do? Well, I would just quit if I was you, because that's a lot of work and nobody likes doing a lot of work. So we just quit. No. At least 4 means 4 and above. So that means that we're inclusive of 4. So that means that we use 4. That's why I put a dot on it. Well, somebody tell me, what do we already have? We already have the probability of what?
Less than 4.
So if we've got a probability of less than 4, and we want the red area, we know that the probability of everything is equal to 1. We're going to take 1 minus 0.0044 or 0.0444, and that's going to give us the complement. And that's going to be 0.9556. Somebody check my math.
That's right.
Now, if you look at that number line, you should see what I'm talking about. We just did 4 or less. I mean less than 4. Sorry, not 4 or less. Less than 4. That's the blue area. We know that the probabilities of all of them is equal to 1. So if I want the red area, I just subtract the blue area from 1. And that gives me the probability of 4 or more. That's why the number line is so important. It helps you see what you're actually getting. Now, if you don't know, let me go ahead and tell you this right now, because I was a student once and I used to try to learn this stuff by osmosis, and it don't work that way. All right? You have to go back. Say again?
And
What did you say, Mr. Lott?
I accidentally unmuted myself. My bad.
Okay. All right. Let me go and show you something. In order to understand math, you have to work at it. You have to learn it. You have to find. And I told you that slide right there was very important. It's so important, I even showed you in 6.1. Now, if you choose not to learn this, then you're going to be the lost puppy in 6.2. So what I would suggest you do, and it's not going to work by osmosis, you're going to have to print this out, write it down, print it out, whatever, put it on an index card, and keep it with you when you're doing 6.2 homework. Okay? Because if you don't learn this, you might as well just don't try any of the problems in 6.2 on the test, because it's going to circle around, it's going to revolve around this right here. And we already talked about it in 6.1. Okay? Now, what happens when they want the mean and the standard deviation? Well, that's when you do mean is equal to NP, and the standard deviation is equal to the square root of NPQ. Remember, most books write Q, not 1 minus P. All right, so I'm just going to go ahead and tell you, I'm going to say Q. When I say Q, that means 1 minus P, the complement of P. So if P is 0.25, Q is going to be 0.75. If P is 0.10, Q is going to be 0.90. All right? So there's the two formulas I showed you at the beginning of the class, and that is the mean, and this is the standard deviation. The good thing about this is most of your N and P's and Q's are going to be easy math, unless you don't know how to multiply numbers. Okay? Here's an example. Write this down, because this is a test question. According to the Experian Automotive, 35% of all car-owning households have 3 cars. In a simple random sample of 400 car-owning households, the mean and the standard deviation. Well, Hubert, how do we know this one is different from the previous one? Well, the previous one is asking for probability, and this one's asking for what? Mean and the standard deviation. So that's why you need to highlight the mean and the standard deviation in this question. and highlight the probability in the previous questions, because there's two different questions, two different animals. And you multiply 400 times 0.35, and then 400 times 0.35 times 0.65, and take the square root of it. What do you have? Somebody answer this question. I want you to answer it. What do you have before you take the square root of NPQ? What do you have? What's it called? It starts with a V.
Variable?
Variation.
Variance, the variation, the variance. What is the relationship between the standard deviation and the variance? We've been talking about that since the first unit. Starts with a S, Q, U,
Squared.
square root. The variance, take the square root of the variance and you get the standard deviation. So if you're on a standardized test and you're asked, what is the variance? Well, the variance, take this highlighter right here. I have to do this because if I try to write on the PowerPoint, it goes bananas. Okay, there's the variance right there, NPQ. And if I want to get the standard deviation, I take the square root of the variance, and that is the standard deviation. So this 400 times 0.35 times Q, which is 0.65, that's the variance. So you need to make that note in case you're ever on a standardized test. You take the variance, and they only give you one number. They only give you one number right here. And they give you a P. Then you can't do anything else but find the mean and the standard deviation. And if they ask for the variance, you just don't take the square root of it, and that's the variance. Now, I put a lot of these on the test. Anybody know why? Because they're pretty simple. Some of them you can do in your head. So you might want to write this one down and put a star beside it, because I put a lot of these on the test. That way, if you miss them, you're even more discouraged than when you started. That's why I do it. Actually, I do it to give you more points. I'm not going to worry about graphing. Graphing is the least of my worries right now. As a rule of thumb, write this down. If NPQ is greater than 10, if NPQ is greater than 10, the probability distribution will be bell-shaped. And that's just kind of like a thing to look at before you even get started. If NPQ is greater than 10, then usually the probability distribution will be bell-shaped. And that's just a little bit of information in case you're just looking at a problem. All right, there's our example right there. It says, according to the Experian Automotive, blah, 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 believes this percentage is higher than the percentage reported. He conducts a simple random sample of 400 cars owning households and found that 162 had 3 cars. Is this result unusual? Okay, so go ahead and I want you to, you've already done this. I mean, this is, now I want you to put this in a bell curve. Remember me drawing the bell curve with y'all in the first unit and put the mean and adding the standard deviation and subtracting the standard deviation? Y'all remember me doing that? Yes, Hubert, we remember that. Good. Now what I'm going to do, I'm going to make this a 10. Because I don't want to have to figure all that in my head. So I'm going to draw a bell curve. I don't have much room, but I'm going to draw it right here. And this is 0.15, 2.35. Y'all remember now? 13.5, 34, 34, 13.5, and 2.35, and 0.15. And of course, we know that this means outliers. And this means unusual. And what does the middle mean? Okay, people, I'm not gonna answer that because we've been going over this since first unit. What is the middle? If this is unusual, what's the middle? Starts with an N. O. R. M.
Normal.
Thank you, class. Boy, y'all don't remember anything. Y'all just learn it and then y'all just forget it, right? All right, so here we go. 140 goes in the middle. 140 plus 10 is 150. 150 plus 10 is 160. 160 plus 10 is 170. 140 minus 10 is 130. 120 and 110. So from 120 to 160, you are normal. What is it asking? 162, Hubert. Thank you, class. So where is 162? 162 is unusual. So is the result unusual? Yes or no?
Yes.
Yes, it is unusual, Hubert. That's right, class. Y'all do know that class goes by a whole lot faster when you talk. Y'all do know that, right? Okay. Appreciate y'all interacting. And there it is. Now they got decimals because I didn't feel like doing decimals. I didn't feel like doing it. So I just raised 9.54. I raised it up to 10. And that's why I did that. That's why they got 159.1 and I got 160. Is this a test question? Oh yeah, this is a test question. And that's 6.2, folks. Now I didn't get many questions. I did get some questions from 6.1. So now I'm going to be waiting on 6.2 questions. When should you turn in 6.2 questions? What day? I'm not going to say it. I'm going to let y'all tell me. Now that I've finished 6.2, when should I get questions on 6.2?
I would say by next class.
Thursday, yes. And what if I don't get a single question? What am I going to assume?
That we understand it.
And I'm going to keep going. See, that's the part that you know, when I had my preaching a while ago or last week, some of y'all are not getting it. Okay? You're supposed to do the homework. If you can't do the homework, you send me questions. If you don't send me questions, then I think you understand it. But some of y'all aren't getting it. And I'm talking about the college algebra class. I'm talking about this class. I'm talking about the 120-24. I'm talking about my calculus class. And I'm talking about my 155 class. There's about 1 or 2 students in each class. They don't understand the process. You send me the questions, and what happens when you get behind? Well, then you're in trouble because you got to rebuild. So you got to send me the questions. This is a new test. It's 4 sections: 6.1, 6.2, 7.1, 7.2. This is a chance for you to make an A on a test. But you got to do the homework, because then you know if you know the material or not. All right? I'm going to shut up. I'm not going to preach. I did that last week. All right. So we are done for today, because I don't want to go into any more. I want to get 6.2 out of the way, and I did that. So I'm going to shut the recorder down, and I'm going to unpresent, and I'm going to take the roll.